Good morning, everybody. I hope a lot of people are here. Let's see who's here. How's everybody doing? How are you guys doing? Oop, let's fix the camera. How's everything going? Who's here right now? What's going on? Snea, first, good, very nice. Who else is here? Beth, classic. Good, good, good. Let's see who's going on. I'm just checking off the list. Did you do your assignment yesterday? Okay, people, I'm just looking. People, did everybody do their assignment yesterday? All you had to do, because what they're doing is they want us to make sure people are participating. Just keep track. They want us to put a grade in every day. And so this week's grades are, well, we got our three different assignments. I could not get 8-11 to post on AP Central. It's there, but it's a printout version. Okay, so if you want to work on that, fine. If you want to print that out, that's fine. You could do that. Okay, but it just for some reason it's not working that way. So let's just get going. Hopefully everybody's doing. Remember, if you ever anything bothering you, anything you want to talk about, you can always just email me directly, and we'll fix it. So don't get all fired up. I think grades are completely updated. If you disagree, if I miss something, let me know, and then we can work through that. But yeah, I think everything's going okay. The AP Central is pushing forward. Every so often we hear something that, maybe at the end of the month we might be back in school, and then other people say no, we're never coming back this year. So we'll see how it is. You never know. All right, so. Let's take a look. Let's take a look at this one. People were asking about this one. Okay, this is the first one. This is the most people asked about. Okay, we got a shaded region right there. Take a look. This is 8.12, number 6. Okay, so you got a shaded region, and it's a parabola, and you got a line 4. That's crossing the parabola, so we can get those points right there. It says there's a number k greater than 4. When that area is revolved around k, the resulting solid has the same as part B. Now, what the part B was, if you did, that's probably what people are confusing. Part B says, what if I took this volume here? Yeah, what type of question is this? Oh, yeah, that's probably what's confusing. Right, but do not solve. All right, so let's just say the area in part B, okay, part B, let's say it was the volume rotated around the, let's do something fun here, the x-axis, whatever, call it B. That is it has the same volume as the solid in B, so we'll call the volume of a solid in B, B, if that was what was confusing you on this problem. The volume is irrelevant. We just want to set our integral equal to b. So basically what they're saying, let's talk through it. Basically what they're saying is this. Okay, there is a certain volume we know that we found in part B, and we'll call that volume B. Okay, so we're going to set up an integral that's equal to volume B. Now, what's the integral that we're setting up? Okay, here is the area. Remember, this is y equals 4. This is y equals x squared. So this is 2 comma 4 and negative 2 comma 4, hopefully. And then now take a look. Here comes the magic. It says, how does the sound? I don't know. The sound seems a little different. Let me adjust the acoustics. Is the sound okay? How do you feel? Do you feel everybody doing okay here? I'm just adjusting here. All right, so we got a horizontal line, okay, y equals k. Okay, now y equals k, let me put it over here, is a horizontal line greater than, remember it says greater than 4. So that horizontal line is somewhere up here. That's y equals k. And we want to find the area when that's rotated around y equals k. I'm sorry, volume. We want to find the volume when it's rotated around k. and we want that volume to equal b. So notice you got two unknowns here. We could not find the volume if this is k. This is an unknown. So they say, well, I know the volume's equal to b. Find the volume. Okay, so basically what they want you to do is set up a volume here. Now, let's ask the question. Okay, if I rotate it, here comes the hole or no hole. This is the hardest part of this because remember, if it's volume, we know, okay, that this is the integral dx or dy, and we have to put the formula here, okay, the cross-section formula. So let me ask the question. If I rotate it around, say, the x-axis, hole or no hole? Here's where you could pause the video after we're watching and decide. Okay, there's going to be a hole. If I rotate it around y equals 4, no hole. Well, if I rotate around y equals k, hole or no hole? Okay, it's going to have a hole in it. Remember, a hole is this equation, and it's pi big radius squared minus pi little radius squared, or no hole, pi r squared. Remember, those are the two. Let me change colors here. We'll make our big radius. Oh, we got blue already. What other color we got here? We got a lot of blue. Here we go. We'll make our big radius orange. Remember, I put a little dot at the middle and go to the further spot, and the big radius is orange. And then I'll make the little radius black. And again, we go put a dot at the middle and go to the closer one. Okay, so then remember, the strategy is pretty easy. We put our pen on the axis of revolution and go to the further function. Now remember, this is the area of the cross-section. That's what we're looking for. So I put my pen on the axis of revolution and go to the further function right there. You see that? That's big radius. And then I take my pen, I put it on the cross-section, and go to the closer function. That's the smaller radius. Remember how we did that? And we got pi, and we'll put big radius squared in here, minus pi, and little radius was black, so little radius squared there, d, and we'll decide that in a second. And remember, all we're doing is this is equal to b. Now, let's see if, now here's where you got to ask a question. You can't just let me talk to the microphone and talk to the cameras and stuff like that. You got to say, wait, go over that part again. It doesn't have to be real detailed if you're not a typer, but you just say something. Okay? Say, hey, I got it. Or if you got it, then don't worry about it. I'm just going, if everybody's silent on the chat, then I'm going, everybody understands it. But if you got to speak up for yourself. Remember, you got to advocate for yourself. It's your time. Okay? This is the new normal here. I'm going to be talking to you on a microphone for at least 2 more weeks. And you got to say, let's talk about this, Mr. Noah. And I like how a lot of people, not everybody, we got about 75% of the people responded back to me for yesterday's assignment. All right, so let's figure out what this is. Are we looking at the area between, no. This, remember, the shaded region is right here. Okay, this is the shaded region. Okay, so when that rotates, that's where we ask the question, hole or no hole. Is this region always touching the green line, the axis of revolution? If it's not, then this part is not part of the region. Think of it like this. And then again, remember we said we don't want to see what it looks like, but if you spin it, it's like a ball, but a tube going down the middle of the ball. Because this is all empty right here. This is the part that's spinning around. So that's why we have a hole in the middle. Between y equals 4 and y equals k is empty. But we're still rotating it around it. Let's think about a situation. As k gets bigger, this object is getting bigger and bigger and bigger. Because the distance from the center to the outside point gets bigger. And the distance from the center to the inside point gets bigger. So the volume does change as k changes. But this is the material that we're using right here. This part, it's empty. So the big radius, first of all, let's decide. We draw rectangles this way. So hopefully by now that's obvious. That's dx. And then the bounds, again, here's what Stan was asking. The shaded part, the bounds don't go. We don't, notice I don't even care where this intersects at k. This is the shaded part, so my bounds are from -2. B is from -2 to +2. I could use symmetry, of course, from -2 to +2. And then we put pi, and then we put our big radius. Let's leave it blank here. Squared minus pi. Don't forget to do this. The biggest mistake is people forget stuff on the AP test. Squared dx. So leave those big spots blank right there. All right, now, as always, top minus bottom. Top is k minus x squared. It's always top minus bottom. All those practice rectangles, that's why we do them, is they're always top minus bottom. And again, top minus bottom. Y equals k, y equals 4. So k minus 4. There is your volume. And of the people that responded, there was 33 people responded, and half, 15 people, close to half, had a question on this. Now, maybe it was B, but that's irrelevant to the problem. Okay, solid, whatever the air volume you found in part B, you set it equal to B. And then they said don't solve it. Notice the two unknowns here. We have to know B because K is unknown. X is known. This integral, if there was just an X there, we could evaluate this integral, no problem. So X is not an unknown. X is the variable of integration. But K, we don't know what it is, so it has to equal something so we could solve this problem. How do we feel there? Everybody happy? We're going to go on to another one. And that's really all we're doing, is just going over some problems. Okay, say something. I'll leave it up here, but I'll move on to 811, number 5. That was the next most missed one. I'm on Schoology now. Here, let's take a look at the computer. I'm on Schoology now. And let's go to 811. Remember where everything is. E-learning. Here's 811. Remember where we're all at. And number 5 was the next one. 3, 4. We're just reviewing. All right. So here we go. Number 5. Again, we're doing a lot more free responses because your test will be free responses. We got region R in the first quadrant. Okay. Set up a do-not integrate variable. Find the volume region R rotated around the y-axis. Let's take a look at what this looks like. If you remember, you get a calculator. If you're still unsure about, how would this graph look. Let's clear those out. We got square root of 6x plus 4. And like I said, the test is with calculator. This one may not be. Oh, I better put it on the screen here. There we go. And then we got, let's take a look at that. Notice, I should have did my own thing. I should have changed my window. Looks like, let's just go zoom standard. Let's go zoom decimal, see what it looks like. All right, there we go. We got a little square root, little check mark. And then we got y equals 2x. And there's our line going that way. And we want to rotate this region around the y-axis. Okay? Now remember what we got here. We want to find the region in the first quadrant enclosed by this. So let's draw our picture here. Remember, in the first quadrant, so we got 2x. That's pretty easy. 2x. Now we got y equals square root. Now take a look. In the first quadrant, for example, when x is 0, this point here is 0, 2. Right? I plug in 0 to the equation, 0, 2. And then it's a square root, so it goes like that. Let's try to find where they intersect. How do we find where they intersect? Well, lucky for us, with calculator, we could find the intersect. If you're square root of 6x plus 4, just want to see where that equals to 2x. And then you could solve for that intersection. But like I said, I'm going to do it on the calculator here. I'm just going to do it on the calculator. Second calc. Find the intersect. You know how to do this. Enter and enter. it looks like 2, 4 is where they intersect. And we could have solved for that by hand, but it's with calculator. So there is the region. And let's put 0, 0 here also. Okay, so there's the region. And now we're rotating around the y-axis. Spin it this way. Okay, so I ask hole or no hole. Here's where you got to say, is this going to be a hole or no hole if we're rotating around the y-axis? Any thoughts? Now, we draw a practice rectangle. Is it always touching the y-axis? If I'm spinning it around that, is it always touching the y-axis? And then you say, oh, yes, this is always touching the y-axis. Okay? So this one, for this part, just this part, okay, from 0, or from, I should say 0 to 2, let me put a little practice rectangle right there. Oh, there's my rotation. Okay, notice, let's make our life a little easier. This part has no hole. But what happens from 2 to 4? What if I go up from 2 to 4 here? Okay, if I put my pen right here on the x revolution, that's not part of the area. So from 0 to 2 is no hole. But from 2 to 4, it does have a hole. You see how this part goes to the further one? The practice rectangle has changed. Okay, you see that? The practice rectangle has changed. So I got to put, let me do green. This one does have a hole. You see that? We want to find the volume. We're rotating around that. So basically, there's going to be 2 integrals right here. There's no way we're going to get around it. We got 2 integrals. This part, top function, bottom function, or I should say right minus left. This one, different function. So if it's different function, we got to change. So from 0 to 2, there's no hole. From 2 to 4, there is going to be a hole. You see that? So now, here's where, if you're watching it later, here's where you pause the video and try to do this yourself. Watching me do it is not going to help you any. Okay, see if you can do it for yourself and then play the video, and we're going to go through it right now. Or if you're like, put the earmuffs on and try it yourself first. Okay, but that's the hard part of this problem. The hard part of the problem is there's 2 different sections when I'm spinning it around the y-axis. There's 2 different sections. Okay, there's one, the section from 0 to 2, because remember, y, everything in terms of y. 0 to 2, no hole. But from 2 to 4, there is a hole. Okay? This is number 5. And so now we say, okay, well, now let's go. Let's go from 0 to 2 first. So if we go from 0 to 2, since it's no hole, it's the integral dy from 0 to 2 of pi, and r was purple, r squared. And then we're going to add to that from 2 to 4, dy again. But this time it is a hole, so it's big pi, big radius squared, minus pi, and little radius, we did in green, little radius squared. And always set that up. Makes life so much easier. Always set up that way. Okay, how do we feel there? Okay, take a look at that problem. 8, 11, number 5. Is that okay? Okay, so now it's just downhill. It's a nice little easy slope. We're going bigger minus smaller. So we got the integral from 0 to 2, pi, big radius. All right, y though, y. So this is x equals y over 2. Got to do it in y. And this is, this is x equals, now remember, it's y, so we square both sides, move the 4, y squared minus 4 over 6. We got to solve for y. Actually, solve for x. We got to put it in terms of y. So bigger minus smaller, bigger minus smaller is 0. I'll just exaggerate and put 0 right there, just so we always know it's always bigger minus smaller. Plus, from 2 to 4, pi, big radius, bigger minus smaller, y minus 2, 0. Minus pi and y squared minus 4 over 6 minus 0. Notice it's not this function minus this function. It's minus 0 every time because it's the y-axis. So we're going from the y-axis right there. All right, how does that look? Everybody okay there? And Ria asked, while we're here, can we just do the same thing, rotate it around the x-axis? Okay, now remember, if we rotate around the x-axis, the practice rectangles are vertical. Okay, and rotate around the x-axis, same argument, is it going to be hole or no hole? Think about it. If we're rotating the same region, it's going to have a hole in it. But lucky for us, there's only one integral. Top function is the curve. Bottom function is the line. Okay, so let's just do that while we're here. Here's this top. Here's this bottom. There's the intersection still. 2, 4. Okay, but remember, it's going to have a hole. We're going to do the same thing. We put our pen on the x revolution. As soon as you put your pen there on the x revolution, you should see, nope, that's not touching this area right here. So I know I need big radius. And then I put my pen on the x revolution and small radius. You got it. You can't say, all right, I'm taking this function minus this function. That's for area. If we were doing area, yeah, we take that function minus that function. But for volume, okay, volume, totally different. So it's integral, in this case, from x equals 0 to x equals 2 dx. And we go pi. We're just doing it quickly. Big radius is the top function. Square root of 6, what is it, 6? Hold on, where's the function? Yeah, 6x plus 4 minus 0. There's the bottom function. Squared. Plus, or say minus, sorry, minus top, minus bottom. Pi, ran out of room there, purple. Top function, let's squeeze it in there. 2x minus 0 squared. See, I'm exaggerating. I'm putting the minus 0 right there. Just exaggerating through on that. Just so to show it's not the square root minus 2x. It's orange, top minus bottom, minus blue. Always do that. How's that one? Okay, let's do another one. Is that okay? Ria, you asked about that question. How's that feel? Is that okay? While I look for the other and the next one. Okay, the next most requested one, I should say. Remember, these are not due. These are not due till Friday. So you still have today to work on them. Tomorrow, we're not meeting online. You work on your problems. There might be a question for you that you have to send me or post something on Schoology just to see that you're still paying attention. We're still engaging. And besides, they told us we have to have a grade for every day. And Mr. Noah has not been doing that because who cares about your grades? But let's just feed the bear to make sure the bear is getting what they want. So I shouldn't say stuff like that. This is being recorded. Just kidding, Mr. Little. Look at number 7. Okay. That was the next most missed question. Had a natural log on it. Maybe that one was scaring some people. Right? But do not, now this is with calculator, when it's rotated around the y-axis. So again, this is a y-axis one. What does that mean? As soon as they say rotate around the y-axis, perpendicular to the y-axis. So my practice rectangles are horizontal. Okay, let's draw this out. It goes here. This crosses down here like this. There's probably natural log right there. And then we got this line right here that intersects down here and intersects up there. Okay, now notice this is with calculator because think about, look at this equation right here. We got natural log of x is equal to x minus 2. Right away, I know I cannot solve that problem. They're two different families. There's the logarithmic family and polynomial family. We have no strategy. Like we, as up to Algebra 2, did not share any strategies on how to solve something like that. So we got to use the calculator. In fact, they've been working on that for a long time, and the best they came up with is a Taylor polynomial. Just to review that, we're going to work on some series and sequences next week. But Taylor polynomial, if I make that into a Taylor polynomial, I can make everything into polynomials, and then we could work on solving it. But for now, we're going to use the calculator. Okay, so let's graph those out. We got natural log of x. Let's clear that. Natural log of x. And then we got x minus 2. And we graph it. And same picture that they gave us. Let's zoom in around that picture. Let's just go zoom. And we'll put a little box around it. A little marquee here. See what we're doing? Just to get a better view of what they had. A lot of times on the AP they give you the coordinates, the dimensions, but for now let's take a look at there. Here comes the line, and we know how to do that. Second calc. Let's find the intersections. Let's go to this one first. And this intersection, you see how we got a weird number right there. Okay, tough number for that. So this intersection looks like 3.1461, comma 1.1461. We could store that in our calculator because we want it in terms of y. You see that? And so it's going to be the y, so that's the number that we want to use. Okay? And then down here, second calc, intersect, and let's go to this one. Scroll on over there so we make sure we get that point. Enter, enter, enter as we get close. And same situation. This is a weird decimal, 0.15859, comma, negative 1.8414. Go to a few. I always go to a few extra decimal places just to see that. You see what I mean? Okay, so there is the intersections. Now we want to rotate this around the y-axis. Okay, so let's ask the same question as always. I'm going to ask the same questions. That should be right there in your binder right now, and your binder should be organized. Remember about the binder. You do get to use your binder on the AP test. First time ever. So have it organized. You're not going to be able to read through your binder and thumb around. Luckily, Mr. Nova prepared you for that if you did what they told him to do, and you're right there. Okay, it should be, that page should just have highlights. It shouldn't have all the work that you did because that's just this white noise. It's background noise. You want the facts. What should we do? As soon as they say find a volume of something, we should ask hole or no hole if it's rotating. What's the cross section look like? It's the same situation, same questions every single time. Okay, so there's no hole. I put my pen on the axis of revolution since it said rotate around the y-axis, and I go to the further function. And then I put my pen on the axis of revolution and go to the closer function. And now I look, and it's right away. It's the integral. It's dy. And I got from the smallest y value, negative 1.8414, to the biggest y value, 1.1461. And I know it's pi. And take this extra step so you don't lose stuff. Big radius squared minus pi. And we did orange is the little radius squared. Get that in there. Write that in there. You're getting points right there. You see, I'm doing the same thing every single time. That should be in your binder already. So now big radius. What's big radius always? Bigger minus smaller. You have it drawn right there. So this is the integral from, let me try to keep everything on the screen, negative 1.8414 to 1.1461 pi big radius squared. Remember, we just leave a parenthesis, little radius squared dy. And so the big function in terms of y, remember, don't forget, if you need to go off to the side, and if you go in terms of y and say x equals y plus 2, x equals e to the y. Remember, if you need it in terms of y, you put it in terms of y. Okay, so big radius is the line. So y plus 2 minus 0. Always exaggerate that as we're learning so you don't mistakenly put this function in there. It's where your dot is. Big radius minus small radius. And then the other one is e to the y minus 0. Everything is in terms of y. The bounds are in terms of y. There is, what was that one? Number 7. 8. 11, number 7. People were asking about that. And we got time. Let's do one more. Let's do one more from which one? Let's do one more from 7.3. 7.3, people were asking. That's another one of the most request one is 7.3, number 3. A little multiple choice right there. Didn't we do that together? The moose population? I thought we did that one already on. Let's watch the video on that one. Let's go to number 4. Number 4, it says on the axis provided. This is one of those on the axis provided ones. See, again, the formatting is kind of messy. Take a look at that. Let me enlarge that a little bit for people to see better. Okay, that didn't help. On the axis provided. Okay, find the slope field. Okay, I can't. It's hard to see there for me. All right, for the points indicated. And again, the formatting is not good, but here's what they want. Here is, let me put it underneath here. Let me just print this page out. Page 2. 1 second here. Let's just print page 2 out. Yeah, I'll get it so we can put it under the overhead here so we can see this. Be right back. All right, I'm back. Do you miss me? So you better say yes. Hurts my feelings. Mrs. Noah is being mean to me. She's telling me I have to go on a diet. Okay, she hit me with the car the other day. I was like, why didn't you go around me? She said she didn't have enough gas. All right, so here's the equation. We had dy dx. The equation for this one is dy dx is equal to x. So let's go right. X plus 1 over y. And we're going from -1 to 1. There's 12 points right up here. And you know what? I'm thinking they might have, think about a differential equation. There's a lot of stuff they could do where they give you a derivative. Remember, we got one big problem, like a 25-minute problem. I'm thinking they could give you, here's the derivatives, maybe the bathtub type problem, and they could ask a lot of questions. When's the min? When's the max? They could here draw a slope field of that, do differential equations. A lot of things they could do with that type of problem. So that might be possible. We want to just sketch the points at the 12 points. Now remember how slope field works. As I put values in, for example, when x is equal to 0 and y is equal to 1, that point right there, when x is equal to 0 and y is equal to 1, 0 plus 1, the slope is 1. Aim it at the other points and just do a little tick mark right there. When x is equal to 0 and y is equal to -1, the slope's -1. Aim it at the points right there. When x is equal to 0 and y is equal to 2, 1/2. All right, 1/2 is less slope. It's got to have a little less slope than this one. So there's no points to aim it at there, so let's try to make the slope a little less. I'm going to aim it halfway over there. And the same thing here, -1/2, so I'm going to aim it halfway to that point. Just make it look like the slope changed. Okay, now how about over here? When x is equal to 1 and y is equal to 1, the slope is 2. Okay, so a little steeper. When x is equal to 1 and y is equal to 2, 1.5. You see how you're just trying to make it look as best you can as the slopes change. That's all you're doing. 1 and negative. You see how the slopes are negative. So at 1, when the slope is x is 1 and y is negative 1, that's 0. That's pretty easy. When x is 1 and y is negative 2, it's negative 1/2. So just make it look like your other negative. No, it's positive 1/2. Let me double check. X is 1, y is so positive 1/2. So make it look like a 1/2 that way. You see, that's what they're looking for. They're looking for how your slopes alter with each other. X is negative 1 and y is positive 1. The slope is 0. X is negative 1 and y is positive 2. The slope is negative 1/2. And you see they're going to give you the points on, did you get all the positives in the right spot and all the negatives in the right spot? And let's finish it off. X is negative 1, y is negative 1. That gets a little steeper. A slope of negative 2. Let's make it negative 2. And then x is negative 1, y is negative 2. Now we're talking negative, so a little less steep than that one. You see, just plug in the numbers in and see what you got. Okay, and sketch the solution that passes through 0, negative 1. So I got my pen, and it looks like 0, negative 1. We start expanding it, and it's like, uh-oh, it turns up here. Turns up, so I got to turn that one up. And this one kind of got to level off right there. Just sketch the solution that passes through. There's no way you're going to do separation of variables and integrate that. Remember, it's plus. Okay, when it's plus right there, you just can't do that. You cannot separate variables. Remember, your separation of variables page should say no adding and subtracting. How's that problem look? All right. Okay, those were, now, here, if you still, I got the list of the most missed ones here. If you still are stuck on a few of them, you still say, Mr. Noah, hey, let's go over on Friday. We're going to do the same thing. Okay, these are due on Friday. And we're going to go over on Friday. I keep moving the wrong way. We're going to go over on Friday more problems. These were you see the theme for today is finish up differential equations from last week and do some area volume type problems. And then we're going to do some series and sequences and some more of those bathtub type problems going by what people were asking about. Okay, so you got to look through your stuff, and if you just don't be shy to say, hey, Mr. Noah, let's do one of those type of problems. Okay? Question. Sneh has a question. Are you asking a question? Oh, this is the tape delay here. Aha, that was a good one. Yes, you may, because I have to go too. So we're going to end the broadcast right now. Hopefully everybody have a good day. Remember, during the day, just email me. Send something. If there's something that's bothering you, just ask a question, and I can help you out with that. Okay? See you later.